Okay, good afternoon, guys. How are you doing today? I want to believe you're fine. I want to believe you are good. So, we want to go today to concept of limits of a function. If you have a function, of course, you should know we have different type of function. But generally, from the idea of function, we know our function is always built on x. Like I say, y equals f of x. Let that be a function. Now, in this function, x is the domain of the function. F of x or y is the range. And this is the function here. Now, let's say I give you a general function. Let's say y equals f of x equals x raised to the, let's say, to the third power. Let me do the third. Now, let that be a function. Now, this function naturally is defined on all set of real numbers. This function is defined. When I say a function is defined, what does it mean for a function to be defined? It means that for a function to be defined, it means it gives us a definite output. By the way, I said f of x is the range. That is the output on y. So x for a function, this kind of function, right? X is the input, y is the output. So when I say a function is defined, it means it will always give you good output, a definite output. What do I mean by definite? By definite, I mean numbers like 2. Numbers like 2 is a definite number. 1 over 7 is a definite number. Minus 0.5 is a definite number. 81, they are definite number. But if I get infinity, but infinity is not a definite number. 0 is definite. Infinity is not definite. So when I say a function is defined, that is, it will give you definite number at every point in real number. Do you understand? Are you getting what I'm saying at all? So that is it. Now, okay, that is what function is all about. Function is just, you have an input, you have an output, we build something around it. Now, when you now have that kind of function, we now ask you, okay, examine the limit. What is limit? That is, I want to test that if that function is approaching a certain input, a certain point in its input, what will be output attain to? If I push a function to a point in its input, that is, let's say this function I have here now, like this one, I say, okay, examine the limit as s approaches to of f of x. That is, I want to see if the domain, this input is approaching. Listen, I said as x approaches or x tends toward. So as x is tending toward 2, what will this function itself? What would the output tend toward? Now listen, not everything we tend toward we get to. So please don't assume that if it is tending toward, I can just punch in the 2. No, we said approaches. Are you getting what I'm saying? Now, that is what limit is all about. You are testing as the input of a function is approaching a value, what will the output approach? That is what the concept of limit is all about. Now, but then limit of a function is said to exist at a point. Let's say I give you a function. Don't mind me, I'm coming back to this. But when does limit of a function said to exist? Now, let's say let f of x be a function. Let f of x be function. And x equal to a be a point in the domain. Be a point in the domain. A point in the domain. Then the limit at x equal to a is said to exist if the left hand limit equals right hand limit. So if both one-sided limit exist, one side limit, the other one side limit. What is limit from the left? Now that will be limit as s goes to a from the left of f of x. Now, if that one exists, number one, limit as s goes to a from the right exists, number two. But that doesn't mean the limit exists first. Now, for the limit to now exist, right, the limit from the left of f of x equals limit from the right of f of x, then we'll say the limit exists. So if they say investigate if the limit of a function exists at a point, you are checking if the limit from the left or left-hand limit equals the right-hand limit. Don't forget that. So if they are equal, we conclude that the limit of the function exists at that point. Do you get what I'm saying? And by the way, let me quickly talk about different type of limit. We have finite limit, type of limit. We have finite limit. Finite limit. We have infinite limit. We have limit at infinity. At infinity. Let me quickly talk about that three type of limit. Now, finite limit is when both the point we are limiting it to is a finite number and the output is approaching a finite number. I get what I'm saying here now. Now let's say as I'm approaching, if a, we know we say limit as x is tending to a. If a is a finite number like 2, 3, 5, minus 2, 1 over 2, 0.5, 0. If a is a finite number and then the f of x, the function is approaching a finite number too, we say that is a finite limit. Now listen, if a is a finite number, but the function is approaching an infinite number, either positive infinity or negative infinity, then we say this kind of limit is what? Infinite limit. And then limit at infinity is when we check the behavior of the function as s is going to either positive infinity or negative infinity. That's limit at infinity. And limit at infinity has a different way of playing it. Let me give you an example of this type of limit before we go to the next thing. This type of limit. Now, if I say limit as s goes to 2 of x plus 4, this is a finite number. If s is going to 2, well, if you examine it well, you should get the function should be going to 6. Now, 2 is a finite number, where it is going to is a finite number. Then we call it a finite limit. Is that clear? I believe you understand it. God bless you. Now, how about if I give you something like limit as s goes to 0 of 1 over x. In fact, let me say positive 0, one-sided limit. I only want to check the limit from the right. Now, as s is going to 0, our function will go into positive infinity. So this limit is what? We call it an infinite limit because our function, this point, right, x is approaching our input. We are approaching a kind of what? A finite input, but the function itself is approaching an infinite result. So that's why we call it an infinite limit. And the last one, let me say I give you limit as s goes to infinity of, let's say, x, or we say x squared. This kind of limit is called limit at infinity, as s is going to infinity. Now, we don't care. The result may be a finite number. It may be an infinite number. We don't care. But because x is going to infinity, we call it limit at infinity. Do you understand? Now, we want to show you how we test limit. Now, at times they give you a question. Examine if the limit of the function exists at this point. How do you go about it? How do you go about knowing if the limit of a function, let's say limit as s goes to 2, you want to know if it exists, limit of x cubed as s goes to 2. You want to know if the limit exists as s is going to 2. Just stay with us. We're going to show you how to do that in no time.